equals 9. So we're finding the X and Y-intercepts. This one thing, it was universal amongst all my classes. Intercepts. That's what you're finding, right? Okay, so to find in this first case right here, the first one right here, are you looking for the X-intercept or the Y-intercept right there? The X-intercept. Because that's when Y is equal to 0. So that looks good. It's X equals 3. That's correct. That's when Y equals 0. So that's 3, 0 once you get that point. That's 3, 0. So then over here, this one is the Y-intercept because you said X equal to 0. Negative 7, Y equals 9. I do like, well, what did you forget there? Negative. Now, is this the proper way to write that? No, because the X-intercept is 3, 0. What's the Y-intercept going to be? What's the Y-intercept going to be?
X, no,
0, comma, negative what? Negative 9 over 7. So don't write it. That's a point right there. Don't combine intercepts because it'll turn into something that it's just not. So when you write the X-intercept is going to be 3, 0, and the Y-intercept is going to be 0, negative 9. Does that make sense? Mm-hmm. So the math looked great. Just make sure you get that negative sign in there. You needed to fill in this table, correct? I think it gave you the X values, and you needed to fill in the Y values. It's really traditional to get the X values and have to put in the Y values. So when you plug in 0 into this equation, you get 3. Plug in 1, you do get 1, negative 1, and negative 3. I agree with those points. You need to make sure your axes have lines, little arrows on the end of them. This point right here, what is that point? 0, comma what?
That one?
Yeah, this one right there. What is it? 0, comma?
3.
Mm-hmm.
Oh, okay.
So what's this one right here? 1, 1. And then what's this one right here? Well, that's 3, negative 3.
Yeah.
So the other one should be, yeah, that's what I was saying, just 1 point off. So that one.
I think I saw this -2.
Oh, you just switched this negatives. I see, -2, -1. Yeah. So now are all those in a line?
Yes.
Yeah. So now you can see, there's your line.
Okay.
Take the extra, a little bit of extra, and polish it up a little bit. Put arrows on things. Okay, good. So then you had a question on 3. The equation is y is equal to x minus 4. If you have y equals x minus 4, what's the slope of that line? The slope lives right out front. We're going to talk about that today. So 1 over 1 means for every unit over it goes, it also goes up 1. So on 33a, it asks you how far up does it go? Every unit it goes over.
Oh, okay.
It goes up 1. That's what it's asking, okay. And then on B it asks, for every unit x increased by 1, y goes up by. Anybody have 33b? 33b? Let's see here. Mar, you guessed 2. So this is for 31. It's for 31. It's going to be negative. For every increase x by 1, y is going to decrease by 2. Because the equation for 31 for that one is y equals negative 2x plus 3. If the slope is negative 2x, that means for every unit 1 over for x, it goes down by 2. Divisions in 2 variables. So we've already chatted about this to begin with. What form did we use yesterday? What was the main linear form that we used? Something for
Standard form?
Standard form. We were using standard form yesterday. Ax plus by equals c. Are there other forms? Yes, there are other ways to write a line. So our first thing we need to be able to do is write an equation of a line given its slope and y-intercept. So Summer, give me any slope you want. Make up a slope, any slope. 3. 3 over 5. Nick, what's the y-intercept going to be? Just pick any y-intercept within reason. 2. So what do we know about this line? If we were going to write this line, we would start with the y-intercept of 2, so it's right there. If we wanted to graph this line. And then what do we need in order to graph the line? We have 1 point. What do we need?
1 more.
We need at least 1 more point. So if we have 1 point and we have the slope, what's the easiest way to find a second point? What? Go up and over by the slope. What's the slope? So that means we go up 3 and? So up 3 and over 5. What's the new point going to be if we go up 3 and over 5? If we go up 3 and over 5, what's the point going to be? It's going to be 5 and what? Nope. 5 and 5. Yep. Be 5, 5. And if we connect these, what do we now have? We now have the line. Now, if we wanted to write the equation of that line, can anybody tell me what the equation would be? We knew the slope and the y-intercept. Summer, what is it? Correct. And what form is that in? Do you remember what that's called? Yeah, slope-intercept form. Exactly. So that's the first form we're going to talk about today. It's the first form we're going to talk about today. Y equals mx plus b. If you have the slope and the y-intercept, you automatically, immediately have the equation of that line. You have the equation of the line immediately. So let's say I gave you this equation right here. Don't write it down. Just tell me out loud. Someone raise their hand and tell me. What is the equation of the line? Nick, what is it going to be? Y equals?
-2.
Nope. Nope.
Y
Y equals?
Y equals.
Yep.
-4 over 5.
Yep. Times?
Times.
Yep. Times what?
-6.
Nope. Let's look at the form again. It's y equals mx plus b, where it's slope in front of the x, and then b is the y-intercept. So -4 over 5 times what?
0.
No, let's look at this again. What does it say right there? Y equals mx plus b.
Y-intercept is 0.
No, but the equation, look, this is the slope right there. You don't plug in anything for x in the equation. X is in the equation.
Yeah.
So it's going to be -4/5 times what? Times x plus what?
0. Or just -2.
Plus -2, exactly. So if we simplify that a little bit, what's the equation going to be? Y equals -4/5 x minus what? 2. That would be the equation. You need the x and the y in the equation. You don't substitute anything in yet. So Alec, yeah, go Mar. Yep.
Is your B always going to be your y-intercept?
Correct. If b is defined as the y-intercept 0b, correct. So b in this case is -2. That is correct. But it has to be in that form. Y equals mx plus b. If there's something other than 1 in front of y, is it in that form? For example, is this in standard form? No. What do you have to isolate? Divide both sides by 2 and you get y equals x minus 4. What's the slope of that line? Y equals x minus 4.
1/1.
1 over 1, so 1. And what's the y-intercept?
That's
-4.
how you graph it.
Correct. That's an easier way to graph them. Exactly. So if we had a line, we had a slope and a y-intercept, what would we just do? We could graph it pretty easily. So if I gave you that in slope-intercept form, y equals 3x minus 6, what's the slope, Milo? Close? Correct. And what's the y-intercept? -6. So if we wanted to graph this, the y-intercept is -6. There it is, 0, -6. And what's the slope? 3. That means you go up 3 and over 1. So if you went up 6, how far over would you go? Up 3 over 1 is the same thing as going up 6 over. Correct. So there it is. What point would that be right there? 2, 0. Exactly. So if we graph this line, looks just like this. Exactly.
So pretty much whenever you have an equation like that, it's always going to be that number on the 0.
Correct. Well, wait, what did you say? That number on this right here?
Well, yeah.
That's on. It's going to be the y-intercept. That's correct, which is when x is equal to 0, which is the y-axis. Correct. Okay. But what about this one? Is this in slope-intercept form right there? That's in standard form. So if we wanted to graph this easily, we would want to turn this from standard form into what form? Correct. Slope-intercept form. So if we wanted to graph this in slope-intercept form, what should we do first? What's a great first step, Harrison?
To get letters attached to x and y.
Well, we want to get and the x attached to the other side. So what should we subtract from both sides?
2x.
Yeah, subtract 2x, and you end up with 3y is equal to -2x plus 9. Now what do I do? Someone new tell me. What should I do, Milo? Divide everything by 3, right? So it's going to be y is equal to negative, what's the slope going to be? -2x plus what? Plus 3. So what's our slope going to be then? Nope. Our slope is -2/3, and what's our y-intercept going to be? 3, 0. Exactly. You could say the y-intercept is 0, 3. So if you graph this, you would start at the point 0, 3 right there. And then what's the slope? You go down 2 and over. So if you went down 2, you'd be at, so there's 1, 2, 3. Go down 2 and over 3. 1, 2, 3. What's that point right there? First of all, hold on. What's that point right there? Down 2. If I go down 2 and over 3, what point am I pointing at right there? No, it would be 3, 1. So now if I connect this, there's our line. What's your question now, Milo?
If the negative sign one doesn't apply to the
No, it applies to one or the other. It's either negative 2 over 3 or 2 over negative 3. It's the same thing. You'll end up at the same place. Same place. Because is this true? Is negative 2/3 the same thing as 2 over negative 3? It's the same thing. So either one, you'll end up in the same place.
But if it was a negative 3y and you applied by negative 3y,
Change the y-intercept, yeah. It would change the y-intercept. It would positive slope and it would change the y-intercept. Absolutely. Absolutely. Great. So here's where it gets a little bit more fun. And this is where you learn something that looks, again, kind of complicated, but it's actually just super helpful. So let's just review for a second. Standard form was ax plus equals c, and slope-intercept form was y equals mx plus b. So that was standard form, and there's a time and a place for standard form, and this was called slope-intercept form. Can someone give me one reason why standard form is sometimes easier to work with than slope-intercept form?
I think it's the other way around.
Well, generally speaking, slope-intercept is what you're going to use most frequently, but there are cases when standard form will be more useful. For example, if I ask you for the intercepts,
Yeah.
intercepts are generally easier to find with standard form, generally speaking. It's not always the case. But there's another form that is super helpful, because are you always going to get the y-intercept when you graph a line? No. You need slope and intercept, or you need 2 points. You need 2 pieces of information. Is one of those pieces of information necessarily going to be the y-intercept? No, it's not. So what you need to point, make one up. 4, 2. And let's say I made up a point, and we're going to call it, let's call it r, comma, z. Have I given you value for r? No. Have I given you a value for z? No. If I wanted to find the slope between these 2 points, what would the slope between these 2 points be?
4 minus r.
Close, that's the x value, careful. What goes on top?
Oh, y. So
What would it be?
2 minus
2 minus z over
4 minus r.
4 minus r. So if I knew z and r, could I plug them in there? Yes, but right now, have I given you values for z and r? No. So right now, is this as good as you can get? Yeah, you can't simplify that. That's as good as you can get. So what this asks you right here is, let's say instead of z and r here, actually, I'll keep that up there so you can see it. What was it, 4, 2? And what was it, r and z? Let's do the same exact thing, but instead of not knowing one point, let's say we didn't know both points. So instead, let's say we had the point x, y, and the other point was x1, comma, y1. What's the slope going to be there? What's this slope going to be? Someone who hasn't spoken it. What's that slope going to be? I'll start you off. It's going to be y minus what?
y1.
And someone else now finish it for me. If the top is y minus y1, what's the next one going to be?
x minus x.
Yeah. We don't know what x is. We don't know what y is. We don't know what x1 is. We don't know what y1 is. But if we knew all 4 of those, could we just plug it into that equation? Yes. This right here represents the slope between any 2 points. The slope between any 2 points. Does it kind of look familiar?
Yeah.
It's the same thing. Usually you see that as y2 and that is x2, but this is just another way to write the slope between any 2 points. That's where it comes from. Do you remember rise over run, delta y over delta x, x2 minus x1, y1, y2? It's the same thing, but this represents the slope between any 2 points.
Isn't it the same thing as y2 minus y1?
It is, but we're just writing it a little differently to suit our needs, okay? What we're writing it as is this right here is going to represent a known point. And this right here is going to be any other point. So why is this important? Well, we're going to get this right here. Take a look at what we have here. M equals, hey, did we just figure this out? That's the slope formula, right? Okay. What happens if on the slope formula, and we'll do this out bigger so you can actually see it. Make it a little bigger for you. So we just said the slope between any 2 points, what was it going to be? Y minus y1 is equal to what? Minus x1. If I want to get rid of a denominator from one side, what do I multiply both sides by? Hold on, Nick. What do I multiply both sides by? If I want to get rid of the denominator, what do I multiply both sides by?
What you want to get rid of?
The denominator, exactly, right? So if I take this right here, and I multiply, what's the denominator we want to multiply both sides by? X minus x1 And x minus what? x1, exactly. So if I do that, what happens to the denominator on the right?
It cancels out.
It cancels out. So you're left with m times x minus x1 is equal to, what is it? Y minus y1 times what? Are you with me so far? If we believe this, if you believe this, do you believe that this is true? But do you believe it? Did we do a mathematically allowed operation? That's my question. Come on. You gotta, yeah, tell me I did something totally wrong. I'm forgetting this right here. I didn't finish writing it. Now what can you do? You can't just drop it out, right? So what can I cancel now, Mar?
The X, Y, and Z.
Mm-hmm. I didn't finish writing it. I'm very sorry. There you go. Now does it cancel? Yeah. Make sure I continue. Yeah. If you have the same thing, you can't just delete things, right? You can't just delete things. So now what do I have? Tell me what I have, Mar. Read it out loud. I have m times equals.
Y minus Y1.
Yep. And there's nothing else over there, right?
And then nothing.
No, there's nothing. It canceled, right?
That's it. Yeah.
We multiplied by the denominator to get rid of it. Okay, that's nice. What form did we really like up here? What was our favorite form? Which one did you guys like a lot? Mx plus b. You kind of do. We almost have that right here. We almost do.
So what is this gonna
We're gonna get to that point in a second. Okay. The y we haven't done yet. All I'm asking you to believe is mathematically is what we've done legal. Yes. We like to isolate y. If we want to isolate y, what do I add to both sides?
Y1.
Correct. So now, if I add y1 to both sides, what do I end up with? M times x minus x1 plus what? y1. What's the only thing left on the other side? What's the only thing left on the other side? Y. What would we like to do to that equal sign? Flip it, right? Do we like having y on the left? So if I flip, is it legal for me to mathematically flip? Yes. So we have y equals equals y1 plus m times x minus x1. Here's what's really cool about that. What does m represent, everybody? What does m still represent? Slope. And what did x1, y1 represent? Any what?
Any point.
Any point. What this gives you right here, everybody, you see this? Is if you know the slope and any point, what can you write? The equation of the line. Immediately. If you know the slope and any point, could the point be the y-intercept, Milo? Yes. Does it have to be the y-intercept, Summer? No. So let's just try using this. And this is how you usually see it written. You usually have it written just like this, right there. Milo, give me a slope. Any slope you want. 3 over 4. Nice. I like using the highlighter. It's kind of fun. Shane, give me any point you want. 4, 3. So the formula we have is y minus y1 is equal to m times x minus x1. What's the 3/4? Where does the 3/4 go? It goes in for what? It goes in for m. That is the slope, so it goes right there. What's the 4 represent? x1. And what does, so that's right here. And what does the 3 represent? The y1, exactly. That's the y1. So if we substitute now, if we just substitute, all we have to do is substitute. We had y minus, what was y1? 3 equals, what's the slope?
4.
Times x minus 4. That right there, is that a line? Yes. What form is it in, Milo? No, it's not. It's not in standard form. It's not in slope-intercept form. This is in point-slope form. Why is point-slope form super helpful? Did we do any deep math to go from here to here? All we did was what?
Insert.
All we did was insert. So point-slope is really cool because all you have to do is insert. That's it. Now, can you transmute this and turn it into standard form if you wanted to? Sure. Could you turn it into slope-intercept form? Yes. But if I ask you what's the equation of the line, and I give you a point in the slope, you can stop right here. Because is this an equation? Yes. Wait, is this an equation?
Yes.
Yes. Is the equation of a line? Yes. If I don't specify what form you write it in, you can stop here. But if I ask you for one of the other forms, do you have to do some work on this? Yes. But if I just say write the equation of a line, stop here. Don't do more work. It happens all the time when people have the right answer. They'll do more work and they turn it into the wrong answer. They'll make a mistake. So if you have the right, stop. When you get what you want, stop talking.
So you wouldn't have to.
Not in this case.
Maddie's turn for it.
She did. She did. And the given point is x1 and y1. So, Summer, give me a slope. Any slope you want. 3 over 2. And Harry, give me a point. 9, 2. Okay, given that slope and that point, please write me the equation in point-slope form. I'd imagine, what did you get? Y minus what?
2 minus 2 equals 3 over 2.
X minus? Done. If I just ask you to write the equation, you're done. If I ask you for a different form, you have to do some more work, and we'll practice that. But what's cool is you have it right there. Any point and a slope, and you're done. Yes, Nick. Form. So this is point slope. Let's say we wanted, what is mx plus b called? Slope what? Yep. So if we wanted it in slope-intercept form, first what should we do? What should we add to both sides? 2. So it's 3 over 2 times x minus 9 plus 2. One word for what we have to do next. Distribute. Y equals 3 over 2 x minus 3 over 2 times 9 plus 2. What's 3 over 2 times 9?
27 over 18.
Yeah, 27 not over 18. It's just minus 27 over 2 plus 2. You multiply just the top because it's 9 over 1.
Right.
And then what's the last thing you have to do here, Milo? What's the last thing? It's not quite there yet. There's 3 things. What do we have to combine?
The 27 and 2.
Milo. The 27 over 2 and the 2, right? So we need a common what? How many halves are there in 2? It's amazing. It's like a ventriloquist. You know, I hear like, it's okay, it's okay. You need a common denominator. So you have negative, what's negative 27 plus 4? Oh, come on, kids. You can do it. Correct. Awesome. So there it is. This right here is in what form? Slope-intercept form. Is this the exact same line as this? Yes. If everything we've done is mathematically true, have we changed the value of the equation? No. This is the same as this. Is there another form we could put it in? What's the other?
4 over 2.
What?
4 over 2.
How did I get 4 over 2?
Yeah.
I multiplied 2 by 2 over 2 so I could get a common denominator. You need to add these two fractions together. You need a common denominator, Nick?
Okay.
How many halves are there in 2? There's 4 of them. So what's the other form we could go into? And this is a little trickier, but what's the other form we could go into? What was the first form? Standard form. And what's standard form look like? Just to remind you, it's ax plus by equals c. So we want to put all the x's and y's on the same side and everything else on the other side. So what's the first thing you think we should do? Be careful. What do you think the first thing you think we should do is? Yeah. Y minus 2 is equal to 3 over 2x minus 27 over 2. Now what do you think we should do? All the x's and y's need to be on the same side, right? So what should we subtract from both sides? All the x's and y's need to be on the same side. So what should we subtract from both sides, Alex? So y minus 3 over 2x minus 2 is equal to negative 27 over 2. X and y is on the same side, but they're not alone. So what do we need to add to both sides, Summer? 2. Add 2 to both sides. So we get y minus 3 over 2x is equal to, hey, we already did this. What's negative 27 over 2 plus 2? We just did that. We just did it. It's up on the board right in front of you. Not 23 over 2. Negative 23 over 2. This right here, what form is that in? Is it in the right order, though? We want it to be ax plus by equals c. Is that in the perfect order? Yeah, what would it be? Negative 3 over 2x plus y is equal to negative 23 over 2. 3 ways to write the same line. Yes, but if I just ask you to write the equation of the line and if you point the slope, you don't need to write it as slope-intercept. But if I ask you to write it in slope-intercept, do you? You do. But please don't unless I ask you to. Don't do more work, you know? Like, just don't. You know, like, you could write me an essay on your thoughts on the American Revolution on your next math test, but you don't really need to, right? You don't really need to. Hold on, Zoya's talking. Let her finish, please. Zoya, yes? X equals 7. Let's graph this. Where does x equal 7? Here, 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 here. What kind of line is that? Vertical. So that's x equals 7. What about y equals 9? Where is that true? 9, 9, 9, 9, 9. These are all the points that have y equal to 9. What kind of line is that? What kind of line is that? Horizontal, exactly. So if you have y equals a number, that is always what? If you have x equals a number, let's say 7, it's always what? Vertical. What's the slope of a horizontal line? What's the slope of a vertical line? We talked about this yesterday. Undefined. It's undefined. It's undefined.